Hello everyone. In this video, we will learn how to calculate defects per million opportunities, that is DPM. In Six Sigma, DPMO, that is defects per million opportunities, is a crucial metric for evaluating process performance. DPMO provides a precise, quantifiable measure of how many defects occur in a process relative to 1 million opportunities. This allows organizations to gauge the quality and performance of their processes with high accuracy. Since DPMO is standardized, it allows for comparison across different processes, industries, and organizations. This helps in benchmarking performance against industry standards or competitors. By measuring defects per million opportunities, organizations can identify, specify areas or steps in their processes that are prone to defects. Before we go through DPMO calculations in Six Sigma, which is very important metric in Six Sigma, let us have a brief look of what is Six Sigma. The Six Sigma is a set of techniques and tools for process improvement aimed at reducing defects and variability in manufacturing and business processes. Why Six Sigma is important in quality management? Because it helps organizations improve the quality of their products and services by identifying and eliminating defects. It focuses on process improvement and variation reduction through data-driven decision making. There are two key methodologies in Six Sigma, that is DMAC and DMA-DV. DMAC means define, measure, analyze, improve, and control, which is used for improving existing processes. While DMA-DV stands for define, measure, analyze, design, verify, which is used for creating new processes or product at Six Sigma quality levels. Now let us see what is defect. Any instance where a product or service fails to meet customer requirements or specifications is known as defect. Then the term opportunities, the total number of chances for defects to occur in a process or product. Defects per million opportunities. As we have discussed that it is a metric used to quantify the number of defects in a process per million opportunities. Sigma level, which we will also discuss in next slide, it is a statistical measure of process capability, indicating how well a process is performing in terms of defect rates. There is a correlation between DPMO and sigma level of a process. Higher DPMO corresponds to lower sigma levels, indicating poorer process performance. While lower DPMO, that is, if a process has lower defects per million opportunities, it corresponds to higher sigma levels, indicating better process performance. Then we will see how to use DPMO to determine the sigma level of a process. So there is a direct correlation between DPMO and sigma level of a process, and the conversion table to correlate DPMO with sigma level is given below. If a process is of 1 sigma level, it will have 6,90,000 defects per million opportunities. Similarly, if a process is of 2 sigma level, it will have 3,08,537 defects per million opportunities. If a process is of 4 sigma level, it will have 6,210 defects per million opportunities. Similarly, a process of 5 sigma will have 233 defects per million opportunities, and a process of 6 sigma standard will have only 3.4 defects per million opportunities. This way, we can understand that how calculating DPMO defines the sigma level of a process. So here is a relation or formula for DPMO calculation. It shows defects per million opportunity is equal to number of defects upon number of opportunities into number of units multiplied by 1 million. In this relation, total defects observed in the process will be equal to the number of defects, while the number of potential defect opportunities which can occur in a product will be known as number of opportunities, and of course number of units is total units produced or inspected. Now, with the help of an example, we will see how to calculate defects per million opportunities. In this example problem, suppose there is a process which produces 1000 units, while each unit has 3 defects opportunities, and a total of 45 defects are observed in 1000 units. Then we can calculate what will be the defects per million opportunities for this process. So here we can see in the problem number of defects are 45, total number of units which are inspected or produced are 1000, and the number of opportunities per unit are 3. So we will put the values in the relation DPMO. So total number of defects are 45. Number of units produced or inspected are 1000 multiplied by number of opportunities per unit, that is 3, multiplied by 1 million, and it comes equal to 15,000. That is, the DPMO for this process in the example is 15,000, or 15,000 defects per million opportunities are found for this production. Now we will see what are the benefits of using DPM. First, it enables precise tracking of defect rates and process improvements. It helps in identifying and addressing root causes of defects. It provides a clear numerical indicator of process performance. DPMO facilitates benchmarking against industry standards and competitors. DPMO encourages ongoing efforts to reduce defects and improve quality. It helps in setting realistic and measurable improvement targets. Thank you.